Hello, everyone, and welcome to another technical session. I'm really happy to be with you today after the break of the New Year, and Happy New Year, by the way. I'm here with my colleague Marsela. We're going to do a small presentation about ourselves. Yeah, thanks again for attending. And don't forget to follow us on LinkedIn if you want to stay up to date about what we are doing, the upcoming webinars. And we do also technical sessions. Marcella does a lot on Azure. She's expert on Azure. So let's talk about, all right. So I am Chafik. I'm an engineer. Basically, I've been building infrastructures for the last 16 years. And I'm the founder of Brainboard, and I'm here with Marcela.
So hi everybody, maybe you remember me from the last webinar. I'm one of the cloud architects at Brainboard, and I'm working mostly, as Chafik mentioned, with Azure, but also with other cloud providers. And we will be together in this webinar today presenting about the infrastructure as code and CICD in the infrastructure.
Yes, and she is our expert, even if like she just explained, I work with the cloud providers. She is our expert. And what we do in Brainboard, quickly, the Brainboard is what we are building is a solution to visually design and manage cloud infrastructures. So you have this, like what we call them, day one and day two. You build infrastructure, and day two, you manage it. And today is CICD day, Marcela. We're going to talk about a lot of things here. So maybe we share how we all started and how the topic about the CICD started at Brainboard. So first, we are sharing with you a real use case, our real story, and how we ended up going deep into the CICD part. At Brainboard, we wanted to look at solutions to implement within our tool. So Brainboard builds the cloud infrastructure, and we had like a simple deployment engine, just allow users to do plan and apply. And then we said, okay, what if we bring a CI/CD component into Brainboard? And we started looking into solutions, and we said, okay, let's go deeper and understand what exists there and how we can use them. And as we collected some knowledge, we said, okay, let's share it with the community and especially highlight what the CI/CD means for this the infrastructure. So the CI/CD, at the beginning, we're going to see what the CI/CD means for the application world. So because it all comes from the application. And then we are going to see why it is needed for the infrastructure. Then analyze the current solutions. There are a lot of solutions, but we're going to pick the most used ones and see how they work. And see also like the commonalities and challenges. And in the thinking process, like we were overwhelmed by the number of solutions. I think we found out that we have more than 200 solutions, I think, Marcela, when we started analyzing it, studying it. And then we said, okay, let's reset our thinking and first understand what is expected from the CI/CD solution. So what is needed to deploy the infrastructure the right way with simple and clear steps and process that everyone can understand and follow and build it in the right way. And under this topic, we're going to share some of the best practices mixed in infrastructure as code and CI/CD, and talk about how to have a successful implementation. By the end, if we have time, we're going to show you like small and quickly demos how we built our CI/CD engine within Brainboard. We took it the other way around, and we would love to have your feedback when you test it and what you think about it. And we would love also to hear the challenges that you have.
Yeah, it would be really nice if we would have the time to do the demo, because I was really excited when I saw it the first time, and I'm sure that everybody will be really excited to see all the functionalities.
Yes, actually, you're right, because we didn't do the hard launch and talking about it everywhere. We launched it like 3 months ago, yeah, so it's now that we are starting to highlighting the value within Brainboard. All right, so before we jump into the CICD subject and how it works for the infrastructure, let's have a look on how it works for the application first. Because when we talk about the CICD for the infrastructure, we want to apply some of the principles that we learn on the infrastructure. So maybe you have seen all this picture, like the 8, the wheel, never ending wheel. And this picture, like especially when we talk about DevOps, everyone is put in this picture when we talk about DevOps, and it's like the CI/CD. The CI is clear; it's like integration, but the CD, yeah, it's two-part.
Yes, and I wanted to ask you about that because there is a confusion about the CD. Sometimes they think about continuous delivery, continuous deployment. So I wanted to know the difference between these two, if you can explain it.
Yeah, this is very good question, and one of the the confusing part. So the CD means delivery or deployment. It depends on the one using it. Usually it means delivery, and these words, delivery and deployment, they are used interchangeably. So if we talk about delivery, it means deployment. Implicitly, it means deployment and vice versa. So the difference between them, the delivery means that the application is ready to go to production. It has been delivered. The deployment, the application has been deployed, rolled out, and used by the end users. So it depends on your definition of done, of course, but in the best practice, the definition of done includes the application is used by the users. So the real users are starting to use the application. All right, so and how it works, like the purpose of the CI/CD in the application work is to take the code from the brains of developers to the hand of the end users. So, and it been in between, a lot of things happen. Sometimes a lot of magic happen. So we're gonna zoom and deep dive into what it implies. All right, so let's zoom first on the CI part. So the CI part, developers, it starts by the developers integrating changes into shared repository. In most cases is Git. I mean, Git is a dominant one. You may use SVN or another one, but Git is the dominant. And where every event, let's say merge request or the branches merged, triggers an automated workflow to run on the CI servers. And you can have like the CI servers, you can have variety of CI servers and variety of philosophies. It may be serverless in Kubernetes, virtual machines, runners, whatever. So it triggers there. And the developers, so when they request to do the change, so they, in the best practice, developers merge changes frequently and as fast as they can. And the workflow need to be, and to trigger the workflow to test, the workflow need to be built. So, and once, what the workflow does, literally, it's gonna check if the condition to be integrated to the repository are met or not. In case the conditions are met, it is integrated into Git repository. In case it's not met, it fails, and it informs the developers to say, okay, here is the feedback loop for these specific reasons, it failed. And this is what we call it shift left. So we want to catch errors and to test as early as possible. We have a lot of frameworks to test. In the feedback loop, we want to know what breaks the code and fix it. And so for the test, it's specific to the languages, but we have like variety, especially in the application side, we have a lot of frameworks to test. So this is in the CI part. And now let's move into the CD part. All right. So once the code is merged into the shared repository, so now the purpose of the CD is to take it, to deploy it, to take it to the end users. and usually means two things. It doesn't necessarily mean that these steps are always there, but in the philosophy of the CD, it means infrastructure provisioning and application release. So we're going to build infrastructure, then we are going to roll out the application. Something very important to know that in a lot of companies, the CD part is not automated. It needs a manual approval because it's extremely sensitive. We need like a human need maybe, and we can include here the QA. QA wants security to give us approval, or we want the product manager to really deploy it. And we have different techniques to deploy. So we can do blue-green, we can do feature flag, we can do canary release. And the purpose is to control the blast radius and understand how the application behaves in real world in the hands of users before general release for everyone. All right, so this is the two parts, the CI and CD. What you should know about the CI and CD for the application is that there is no one-size-fits-all solution. And as we are going to talk about the CI/CD solutions for the infrastructure, it's important to highlight this. Even for the application, there is no no one-size-fits-all solution. And in most cases, the architecture of the application matters. And this is maybe like one of the less talked about topics, how the architecture of the application matters, especially in the cloud native worlds where the architecture of the application is sometimes literally the architecture of the infrastructure. And just to give an example, you don't deploy, if your application is deployed in Kubernetes using maybe Argo CD, you're not going to deploy the same way as JavaScript application that is just bundled as a minified JavaScript in S3 or blob storage. Two other important things. The main objective of the CI is to be the gatekeeper to get integrated into the main repository. And in this philosophy, in this objective, there is like the feedback loop where we want to fail fast to fix it and send again the changes to be validated to get accepted into the repository or not. And on the other hand, the main objective of the CD is to control the deployment. Control the deployment, it means we want to maybe deploy it manually or trigger auto deploy or involve more teams or whatever the strategy. The purpose of the CD is to control the way the application is rolled out to users.
And that's really nice that you mentioned the architecture of the application, because I've seen many cases where we need to check even the technologies that are being used in the application, if they are using Java, etc., because even the cloud infrastructure is affected by the architecture of the application. So that's a really good point, I can say.
Yes, exactly. And we are moving more and more towards a cloud native. Even those who are migrating from on-prem to the cloud, even if they do the shift and lift and keeping the architecture the same, at a certain point, they will move into to meet the native cloud services.
That's true.
Yes. So now let's apply, when we want to apply these principles to the infrastructure. So the most known topic is the infrastructure as code. So, and let's see how we can apply all that to the infrastructure. This is widely known, infrastructure as code. What does it mean? It means that we want to manage the infrastructure as a piece of software, or as a piece of code. This does also mean that we want to apply the code principles to the infrastructure. This is really important because, and talking about the code principles, we want to take advantage of the code. That's why we wanted to apply this to the infrastructure. So what does it mean? It means that we want versioning. In case we want rollback, so it's going to be easy. I just check out the changes before and roll back. We want tests before doing any change. We want to be sure that the changes we bring doesn't it complies with what we want to do. We want to minimize the drift between environments. We're going to talk about the drift later. We want idempotence, like every time I execute action, I want to have the same results. In the infrastructure, it may not be exactly this, but this is what we want. We want also deployment strategies, like how we can move from staging to production to QA, to how we can strategize this. And also one of the very good examples is to shift left. Like if there are errors, I want to know them as early as possible to fix them and go fast. And also security, which is one of the hottest topics that we have. I can, like the security means that we can modify any security checks and make them part of the process to harden the way we build infrastructures. So yes,
Yes,
Marcela.
I'm curious at this point because based on your experience, what security checks would be relevant for a simple infrastructure?
Yeah, this is one of, like, I think one of the questions that every cloud architect or DevOps, SRE, platform engineer should ask or have already asked. So one of the basic checks about security is first, understand the blast radius of the change. So what is exposed to the internet, how users get authenticated, who has access to what, who is authorized to use which resource and why. So all these kind of security checks need to be incorporated. And we have a variety of tools that some of them is pure security, some of them is based on CIS benchmarks, some of them are policy as code. We're going to see some of them in the examples later. But yeah, security for the infrastructure is extremely relevant because the infrastructure, yes, someone is mentioning penetration tests. Yes, everything that makes the infrastructure robust and make the infrastructure secure should be incorporated. Then, I mean, it depends. There is also one important point here is the scope of the security. Is it managed by the security teams, or is it managed, is it like a sport game within a company? Everyone cares about the security, DevOps, cloud architects, and everyone, or it's just for a limited team? And then, like the last point, and this is just some examples. It doesn't mean this is an exhaustive list, just sharing one of the advantages that we want to take from the application and use them in the infrastructure. The other part is auto-deploy, which means I want to deploy based on decisions that I can codify in the process. And I can say in the process, if everything is green, I can deploy the infrastructure. I'm not saying that this is what you're supposed to do the auto deploy, but I'm talking about just the possibilities. So why this is not what you're supposed to do, but just sharing possibilities here. The first thing is because the infrastructure is not an application. And this is a fundamental point to understand. Even if it's managed the same way with code, it's not an application for many reasons. So we're going to see the reasons right after why the application is, the infrastructure is not an application. And the second point, as we talk about infrastructure, application, there is like a concept, mutable or immutable infrastructure. And in the development, like now best practices and way of working, we talk a lot about immutable infrastructure. And the immutable infrastructure literally means it's gaining a lot of traction. It means that instead of releasing the software and changing it in place, I'm going to replace it. So if I release in Docker image, I'm going to destroy the old one and create a new one with the modified version of my software. If I release a binary, I destroy and recreate, and so on. And this is this philosophy that works perfectly great for the application. Sometimes it's not applicable to the infrastructure. Just to give you an example, and maybe you know it better than me, Marsela, about firewall rules. If we have a firewall and we want to update the firewall rules, we are not going to destroy the firewall and create the new one with the new rules. We're going to just update the existing firewall. And the same goes, for example, for database. If you want to update a database, you're not going to destroy the database and apply the changes, but apply the changes on an existing one. So
Yeah, but for some resources, you have to do it. You have to destroy it and create it again. So we have the two possibilities.
exactly, that's why we need to take it with a grain of salt and not just, yeah, in some cases we'll, as you said, we literally um, destroy and recreate. So, and when we compare like the infrastructure, the application via the infrastructure to understand better what's the best CI/CD solution for us. So the application is usually bundled as an artifact. So it can be a Docker image, it can be a binary, it can be a .jar file, it can be just a JavaScript minified, put in blob storage. It can be like any artifact. In the other hand, the infrastructure, the is the target. So we want to build infrastructure. It's not something that we build to release to be put on top of something else. The second point, and we were like, we were talking about tests just before the webinars, like the framework of testing and so on. For the application, we have like an extensive list of frameworks to test. Usually, and in most cases, they are language specific. The way we test Golang is not the way we test Python. It's not the way we test JavaScript and Java and so on. And for the application, we have like fewer frameworks for tests. When you say fewer, you can find maybe 10, maximum 12, 15. Most of them like needs that code knowledge. Like you need to codify something in a specific, to write, to develop something for in a specific language. Those that you can use off the shelf like are really few. And to test the infrastructure, like usually you create complete environment and you destroy it. So testing it just means, maybe in Terraform, maybe those who are used to it, maybe they laugh about it. Testing in Terraform is just doing Terraform apply. So, and some security checks. And we're going to talk about, yes, later how share with you some tools. And I even have a repo to share, a GitHub repo to share with you that contains some security tools. The other part for the application, about the application, the rollback are extremely easy. So to roll back the application, as it has, like it is within the philosophy of immutable infrastructure, we just roll back the previous version by replacing the existing one, and so on. Roll back the infrastructure is not that easy because sometimes it may include destroying the infrastructure. And this is extremely important to understand and to plan beforehand that like this is something that needs attention and that we need to pay attention to it. All right, the other part, the other points as well is about the drift. And this is one of the like main topics, especially in the infrastructure, or maybe this is related mostly to Terraform. But there are like two types of drifts. There are drifts between environment, like you have QA, dev, staging, QA, and production. You can create a drift between these environments. And the second type of drift is the drift between the production and what is supposed to represent the production in the code side, which is mainly the branch main. Like in the best practice, the branch main should represent the production. Which means for the application, there are all the mechanisms to make it hard to create a drift. Like no one will connect, or maybe no one, maybe few people will connect physically to the production servers and do changes that are not reflected into the code. But in the best practice, you have the same package that is installed throughout the environment, QA, staging, and so on. On the other hand, for the application, even if you use best practices and you use it with code, let's say you have an incident and you like security incident and you need to fix something quickly, you are not going to wait for the infrastructure, to change the infrastructure, to wait for the Terraform state refresh to take 2 hours. You are going maybe to the console directly and change it. And welcome to your first drift when you manage the infrastructure. And this is a common scenarios. Maybe it depends on the team and the discipline, but in some cases, when emergency action is needed, waiting like all the checks to go green before you deploy So maybe we do it like in second action. So we fix it, then we write the code to be compliant, and wait for the checks to be compliant with the changes that we have done to production.
Yeah, drifting is one of the hot topics. Like many customers ask for the best practices because it is common to have different environments and make sure that when you are going to production, you have done all the tests. So that's an important point. Yeah.
Exactly, and especially for troubleshooting, how you make sure that the environment like staging, QA, and production are close to each other, that you can really have true tests, like real simulation, to be confident to go into production. There are different strategies that we can.
And we know that in most of the cases they have slightly differences. So
yes,
it's a challenge, we can say.
Yeah, for the infrastructure, to me, it's something may happen natural. Again, talking about the security, maybe in the staging environment, you will not replicate all the firewall rules or all the security setups that you have into production because you are in sandbox and staging. So which means the infrastructure is not 100% compliant with what you have into production. So this is the nature of the infrastructure. And also one of the important points, and again, this is not like an exhaustive list, but we picked the most painful ones, the most important points to keep your attention on them. So it's easy to manage the dependency between the infrastructure and the application, because let's say the application needs an infrastructure. It's easy. Let's first provision the infrastructure, then roll out the application. For the infrastructure, it's a slightly different, because sometimes you need to understand the dependencies. Just a random example, like to create the subnet, you need a VPC. So you first create the VPC before creating the subnet. And this is a very simple example, but there are like few cases or a lot of cases where you need to understand the dependency. Maybe like what I've seen like users doing, and myself when I started learning, I'm doing this, like test, fail, and learn the dependencies, put them into the code, in the design, and that's it. Every time you know that this resource depends on that resource. All right, so now let's, as we are talking about cloud infrastructure as code, let's see what are the languages that we have in the infrastructure as code and how we work with them. So we picked really the most used languages. There are like few other languages that you may find, but we picked the most used one. So CloudFormation is specific to AWS, and ARM templates or BSAP are specific to Azure. So the cloud providers created their own, we can say, language to provision infrastructure on their platforms, which is natural. Ansible historically was known for configuration management. At the beginning, I remember I was working with Ansible. It was like purely for configuration management. And I know, Marsela, like the debate between Terraform and Ansible. Maybe we're going to talk about this later. Terraform is the dominant one, and we are seeing like it's the most grown language. We're gonna share with you some statistics, and we are seeing like also Pulumi have a different way to build the infrastructure. And I think you have a question. I do remember when we were talking about it.
Yeah, we were discussing it earlier, and actually I've seen discussions for the differences between Terraform and Ansible. Actually, Terraform is used for provisioning and Ansible is used for configuration. So the difference between those two is like easy, let's say, even though Ansible is being used also for provisioning. But I'm curious more about the differences between Terraform and Pulumi. Like when can we use Terraform and when Pulumi? What do you suggest?
Yeah, like a very nice highlight about the difference between Ansible and Terraform. The debate is now like set it down. We may replace Ansible when we use Terraform, or we may keep it for configuration management, like we separate concerns, Terraform for provisioning, Ansible for configuration management. But with Pulumi, actually Pulumi is bringing a new way of thinking on how to build infrastructure. So like with Terraform, they created their own language, HCL, which is HashiCorp Configuration Language. It's kind of YAML. It's YAML-like, but it's not YAML. And you need to learn this language to be able to deploy, to provision the infrastructure. The philosophy of Pulumi is they want to give to the developers the power to be able to create the infrastructure from their preferred language. So if your preferred language, you code with JavaScript or Golang or Python or whatever the language that you like, you can use Pulumi to create the infrastructure directly from your language. There are like pros and cons. Seeing like some of the users choosing Pulumi over Terraform. I don't think it's now like, it depends on the audience. I put it like Pulumi is for developers because they put it into the language, and Terraform is for cloud architects, for DevOps, for platform engineers, and so on. So this is the main difference. How to choose is really based on first the learning curve that you want to have with both the principles that comply with your processes, with the team skills, with what the future you want for infrastructure. But the most used one is Terraform. And
before we continue, we have also our listeners that are confirming that Pulumi can be used, like you can use your own programming language to build it. And I see also we have a question about Terraform. I didn't want to skip this question because one of our listeners is asking what strategy we can use to differentiate Terraform inputs for test or prod environments. Like it's one of the ways we use to distinguish between these two and to deploy in these two with the input variables. So can you say something about this question?
Can you repeat the question, please? I didn't get it.
What strategy we can have to differentiate Terraform inputs for test or prod environments?
Terraform inputs, there are different strategies. The first one is isolation, and we're going to talk about it in the best practice. So you isolate the environment, test, staging, QA. I know that the pain point of cloud architects is to not repeat themselves. Like they have the code for production, they just change the variables and use it for staging, change variables and use it for QA. So the best strategy is to isolate. The other one is naming conventions. So, and there are naming conventions in terms of what is specific to the environment and what is global for everything. At Brainboard, we took the solution to really isolate everything. So if the user is interested to understand how they can do it into Brainboard and we dig deeper, we will be happy to show you, because it's not about input and output. It's also, when you use Terraform, it's also about the Terraform state and how the Terraform state is managed. And this is one of the topics, sensitive topics, especially in the CICD, like how the remote backend is managed, how the state for the environment is managed, who has access to what, is the state visible to the other one and you can share it or not. So there are a lot of hidden, or we call them day two topics that you need to think about beforehand to manage the infrastructure. Yes, and talking about Terraform, just sharing with you some statistics from, I took it from GitHub Octoverse, and this is the official website of GitHub Octoverse. And this is like the state of open source. So they are mentioning that HCL is the fastest growing language on GitHub, like before even JavaScript, TypeScript, Rust, and so on. So you can see it here. Actually, you can search it on the internet, and if you want to read the report, it's there. So that's why when we started looking for the languages and infrastructure as code, we wanted to understand what's the dominant language, because we bet on Terraform at Brainboard. So we were completely compliant on Terraform. We said, okay, let's first make sure that we're betting on the right language. So Terraform is the most used language, and now we understand that Terraform is the best used language. Let's see what solutions we have that we can use to manage the CI/CD part. And surprisingly, we found crazy numbers of solutions. And yeah, it's like we were talking about it before the webinar. It was like more than 200 solutions. And just to give you an overview, glimpse about how it looks like, you have the CNCF landscape. Actually, the CNCF, it's a Linux foundation dedicated for cloud computing. So it's like cloud native computer foundation. Their role is to understand, their role is to bring to the industry a proper way to build different aspects. So if you can choose here, if you want to see all the solutions that exist, you can choose here, for example, for continuous integration, or click here to open the continuous delivery foundation. When you click on the CD, just the CD, we have like 119 solutions. Of course, not all of them are true solutions. Some of them are reported as customers, but again, like the number is crazy, and this number is just companies that paid to be part of this listing. So we don't count all the other solutions that are not listed here. And so with all this number, go pick one to manage your infrastructure. It becomes really challenging. So what we said, okay, we said, let's go to the basics and let's pick the CICD solutions that we know and that are widely used over there. And let's analyze how they work and how we can adopt them and what's the best choice. Because like even in the CICD, there are a lot of confusion in the solutions. Some of them just do the CICD. Some of them expand to project management, task management, roadmap management. So it's like a mix of things. So we picked Jenkins, GitLab CI, GitHub Actions, AWS Code Build, Azure DevOps, Argo CD for those who use Kubernetes. It's the most used one. Travis CI, Circle CI. So, okay, let's look at Jenkins and how it looks like. So, Jenkins, if you want to have a CI/CD solution for the infrastructure, you need to create the stages. So the stages, you create them with with specific syntax. Groovy, if you want to go deeper, you need to learn Groovy to work with Jenkins. Once it's deployed, you are gonna have the visually how the pipelines looks like and understand the dependencies and get output. The GitLab, the same thing. It's not Groovy, but it's YAML. So you need to understand and learn the YAML language specific to GitLab CI to be able to build stages. Once it's built, it's give you the visual with the output that you can see it. GitHub Actions, the same. It looks like GitLab. It's based on YAML, but it's different, but it still is YAML. You write it in YAML. Once it's deployed, you have the visual. Azure DevOps the same, and like all the solutions behaves the same, more or less. You have to learn a specific language to codify the pipelines. When it's executed, you have a visual, and you have the output. And so we said, okay, what are the patterns and how should we think about it? So we said, okay, these, like most of them, they have commonalities and they have challenges when it comes to the infrastructure and how to use them to the infrastructure. So every one of them, for example, have their own language. And I see language, it may be like for some of you, it's not a language, it's just syntax, it's just markup language, it's just configuration language, whatever. It's something that you have to learn from scratch. And I do remember I did in one of the companies I worked with before, we did a migration from Jenkins to GitLab, and that was crazy because we literally rewrote every single Jenkins pipeline into GitLab CI pipelines, and it's like redoing it from scratch. So migrating from one tool to another is not that easy. I know that they are now starting to offer migration from different tools. I've seen it in GitHub. But even in GitHub, it warns you like it may work for, it may work for 90% of the use cases, but you still have maybe 10% to adjust it manually. The second commonality, and every point of this is a commonality between all these resources and the challenge in their own. So they all have their native language. This is something shared with all of them, but you need a learning curve. There is a learning curve when you work with when you start working with any of these tools, and when you switch between them, you start from almost from scratch. All of them allows you to automate the decision-making process. So, and this is like the very important part. Based, like, you can codify the decisions that gate move into through stages before like integrate into the main, or before going into production. I want to gate this with decisions, and I can automate in the workflow these decisions. This is a commonality and challenge at the same time, because you need to understand deeply how you can build these mechanisms to be able to have a decision making process set up correctly. The other point is they are generic for any language, application, or infrastructure. They don't make the separation. This is a very like a commonality between them and a challenge in its own, which means like if you want something specific for the infrastructure, you have to tweak it a bit to make it work the way you want. Sometimes it may requires like that you maintain kind of plugins, open source tool that you use, and so on, part of the workflow. And like now we are seeing, like we have been talking with this lately, Marsela, like most of them start to be like going out of the scope of the CICD, like task management, DevOps process management, ticketing system, like everything related to the way developers work is there. So the scope is very big. And if we pick just Azure DevOps, for example, you can do like everything, even maybe order a pizza or order a coffee. So with these changes and commonalities, we said, okay, the challenges and commonalities, we said, okay, let's focus on the infrastructure and what is expected from CICD solution for the infrastructure. So the first thing is testing the infrastructure. So testing the code that we write, and like within the test, like the code, pure code, whatever the code. Throughout, here we are like more focusing on Terraform. It works the same for any language that you pick for the infrastructure, except maybe Pulumi, that you have a separate framework for testing. So it should be easy to integrate the testing solutions with the CICD, and we should be able to, like in the test security as well, and cost. This is like the most important points for the infrastructure. And like we have been talking about security, Marsela, and we had like few questions about the security. So
yeah, related to security, we can say like usually there are tests that are done for security. Like even one of the challenges that I had in based on my previous experience is the pen tests that were done and the security checks. So regarding this part, how do you think related to security, like should testing always be like done automatically through a process? Should this test be done like manually after some time? So what do you think?
this is like a tough question, even if it's like simple but tough. Simple because, okay, we want the test part of the CICD automated and like done, end of story. Sometimes it doesn't work this way, especially for the security, for example. Some security guys, they don't want to do the test automatically. They want to check everything themselves and go through an approval and all of this. So like one of the best practices is to bring everyone around the table and have the same and work as a team, and work as a team and make it automated. Whatever there is a new change and there is a new thing happening, for example, in the outside of the team managing the infrastructure, let's say the security team has a new a policy that they want to codify, it's better that they do it together with the DevOps team and build it part of the process. And this is like a discipline. It's a process, but it's more a discipline. The other part from what is needed for the infrastructure is like notification. We want to notify a person, a team, or a system, maybe reach out to a ticketing system to say, okay, the infrastructure is deployed, update Jira, whatever, ServiceNow, whatever to update. It should, from what is expected, it should have an approval management system. Of course, a lot of solutions have an approval system, but the very important one is approval combined with protection against parallel executions. This is specific to Terraform. I do agree, and because this is like one of the most language we are talking about it here. What does it mean? It means, especially when we manage the infrastructure, it means when there is an ongoing process that is modifying the infrastructure, it's better to lock this execution until it ends. And this is because for Terraform, it's like this, the answer is easy. We have the Terraform state. If it's corrupted, I mean, you deal with it. You have a big work to do, manually testing everything manually to make it to fix it. But I personally wished there is a system that allows me to lock the execution. So what usually do is we use, like with Terraform, we use a remote backend with DynamoDB or any database that does the locking, which means like we do a lot of tinkering here to make it work. So what if this should be part of the CICD that is aware of the infrastructure? And there is also, we can include here the drift detection. This is one of the hottest topic we are talking about it. To me, I consider drift detection outside of the scope of the CICD, even if, because it's like part of the infrastructure lifecycle management or monitoring. But usually we add it here because the remediation should come from the CICD. Because if we have like remediation action to redeploy the infrastructure, the CICD will redeploy the infrastructure. And okay, this is like what we expected from the infrastructure, and said, okay, let's see what are the tools that we have and we use them. So you can search like a lot of them. I have here a repo to share with you. So this repo here, it contains like some of testing and tools that you can check and see what works for you. I'm going to share it here on LinkedIn, and put it on LinkedIn and also on our YouTube channel that we keep track of it. So yeah, there are a lot of solutions. The most used ones and the most what I've seen around me as like we have been building infrastructure with many customers for at least 3 years. We are seeing like some of the tools emerging and using frequently. In terms of Terraform code and check, you can use the native Terraform sub commands or Terraform commands like plan, verify, and FMT. The verify is just verify. It's going to just verify if the code is valid or not. The plan will show you what's wrong with it. And again, if the plan is working, doesn't mean that the apply will work. This is like a whole story. Yeah, the apply, we reach out to the cloud provider, it does the action, it may be rejected. It's not related. You can also use tflint for the linting of the code. This is a very good one. For security and policy as code, so we are like the most used one I'm seeing are TFSec, Chekhov. TFSec is based on CIS. So, and it's very nice tool, by the way. You have, with CIS, you have the remediation action. So you can see, like link to the documentation and see how you can do the remediation actions. And Chekhov as well is like, Chekhov is called policy as code. So you can code your policies and use them. Terrascan is, it scans infrastructure, but based on the CIS benchmarks. So you can have like clear view about how your infrastructure looks like in regards with the CIS. OPA is so powerful, so strong. So this is like open policy agent. You can define what is called RIGO policies and execute them on the infrastructure. You can go really deeper with OPA, but it has some like a learning curve, and you need to understand how it works to be able to use it. In terms of drift detection, now Terraform natively support this. They create an option, I think, a year ago called Terraform Refresh. So you can, based on this, you can understand what drifted in the infrastructure, or if you are maybe if you are used to use driftctl is great open source tool as well. They've been acquired by Sneak, I think. And in terms of CICD, like there are like some kind of tools, paid tools, but in the open source space you have Atlantis, very good one. This one, and by the way, the founder of Atlantis has been hired by Terraform, so maybe by HashiCorp, sorry. So maybe they will integrate some of the functionalities inside. And in costs, the most obvious and used one is InfraCost. We use it at Brainboard. I personally use it to estimate the cost. It's like cost estimation. You can do a lot of things with it. Yeah, it's a very nice tool. So this is like one of the tools that you can use off the shelf, put them into your pipeline. Like, just be aware that if when you start using these tools, it means like you need to maintain these tools, to update them, upgrade them when things are wrong. You need to fix them. You need to keep an eye of like, the latest updates, what changes they imply, and so on. So it's like you have something to manage besides the CI/CD. All right, so now it comes to the best practices. After seeing all this and how we build it, so at Brainboard we ended up having a different way to build a CI/CD. Maybe we can show it. We took it like we thought about it the other way around. Instead of codifying everything in YAML, then having the output in pipelines, we said, okay, what if we just design the pipelines visually, the stages and the parallel tasks, and get it executed? Because what matters is I want to put specific processes specific to the infrastructure into workflow that makes sense to me. So maybe, we're going to see it at the end. So one of the best practices, and this is a mix of the best practices related to the IaaS, infrastructure as code, and CI/CD, because the difference, because like the CI/CD, the IaaS is the concept, and the CI/CD is the implementation. So they are tightly related. So that's why we put all the best practices there. The first one, maybe it's like obvious. Everyone have one source of truth for your infrastructure. It may be obvious, but it's not that obvious. So really keep the source of truth in one place. It could be in the code, it could be manual, it could be whatever you decide, but keep it in one place. You will save a lot of headache to your team. The second point, a very important one, and I'm on purpose sharing things that I personally didn't find when I searched in different articles, because we wanted to, when we created the slides with Marsela and the team, we wanted to bring something like more value, something that is not present or fragmented in different documents into the presentation. So the drift plan to reduce drift. So whatever, like the two types of drifts, keep in mind what you can do to remove the source of the drift in the CI/CD. So the source of drift may be human, or maybe the process, or maybe whatever that may create this drift. Work on it seriously and find the root cause and fix it. The third part is have clear separation of concerns. And Marsela, you asked about the environment and the different environment, like staging, QA, dev, and so on. It should be separated. To me, they should be completely isolated, even if the code is it's shared, but there are different mechanisms to have shared code but completely isolated. And also about this point about separating the concerns is like use different subscriptions or credentials for different things. Keep the state isolated for every context. Keep it try to scope it and have only and work only within the scope. And the other point that is well known by maybe everyone is to keep yourself and keep your infrastructure dry, which means don't repeat yourself, like by creating reusable building blocks. And this is really helpful. With Terraform, you can do modules. With all the languages, you can create the same thing, templates or the similar mechanism, and reuse them because you're going to build knowledge. And as you build the knowledge, it's better that you capture this knowledge into a specific building blocks that everyone can take advantage from. The other part as well, in the best practices, know your context. And this is important. Like, are you application based, let's say, team or pure infrastructure team? And there is no good or bad way. It's just important to understand. Like, and also, like, are you cloud native way? The application, is it cloud native? And we are talking about cloud native. Like, the architecture has literally the architecture of the application is literally like 99% of the time the architecture of the infrastructure. So you need to plan for it accordingly. Or you are pure infrastructure, you don't care about the application, you are like you are at a different level. So you plan for it differently. And sometimes you try to mix both. I don't see very successful implementations. So know your context and work within your context. And within this, keep things small. And this is very important one. So keep it small for so many reasons. To reduce the blast radius for the infrastructure, to have more control change. Like, if you bring a change, it's going to be you control it as small within a limited scope. Even when you use Terraform, the refresh state is going to be fast, which means the execution deployment time will be faster, which means if you need to roll back, it's going to be even faster. So it's really important to keep it small. And again, about security and isolation, keep the infrastructure isolated, especially in the zero trust. If the team and the company is adopting the zero trust philosophy, everything is separated, everything is isolated, everything is authenticated when they talk to each other. So keep it isolated, and especially for Terraform and for the Terraform state, keep them isolated. And we compiled with Marsela some of the successful points to have a successful implementation, and this is what also we realized. So maybe Marsela first, if you share with us some of the challenges that you had. You work with big companies, and you have seen challenging infrastructures. So what are the things that comes at the top of your mind of the challenges that I've seen?
Well, when I'm thinking of challenges, the first one would be working as a group, working as a team, and the processes. Usually, in big companies, this is an issue, and the process is slow. Then not having a well-defined access hierarchy, even in cloud, but also for the whole process of the CICD. Sometimes there is a lack of expertise in infrastructure as code, if the company is using Terraform or other tools. Not everybody knows how to use them, so sometimes it becomes a challenge, and it's difficult to work as a team. Then companies have their own policies and do pen tests, as we mentioned, and security check based on these policies and on well-known standard policies, CIS benchmark, as we said before. And one of the main challenges was overcoming the time-consuming obstacle of ensuring that infrastructure automation scripts remain compliant with company policies. So this was one of the challenges, because sometimes pen tests were done not in the moment when the infrastructure was provisioned, but maybe some months after it was provisioned. And we had to delete everything and create it again because it was not compliant with the policies. Then managing different environments. I won't stop on that because that's a real challenge. Also, one of the concerns and one of the challenges was the visibility of cloud resource consumption. So it was the cost. And if customers had some budget and they wanted the infrastructure to be within budget, it required a lot of calculation or using like open source tools. But we didn't have much visibility in the moment that we were provisioning the infrastructure. So these were some of the challenges, I can
Okay,
say.
and as you can understand, she talks a lot about security. Yes, this is one of your favorite topics, I guess, Marcella.
Yes, that's true. As a cloud architect, we need to make sure that the infrastructure that we are building is secure, is isolated, as we said, but it's also within the budget and also it's delivered fast. So I'm worried about all these things.
Yes, and yeah, and as you said, like the first point was a team, and this is so true. The CI/CD is not just a tool. You can consider it as a tool, but it's a what do you call it? People process tooling setup. So you are putting the CI/CD, we are putting in place process, and people will work on it. So invest in this process and be aware that it's three of them. And also don't overthink it from the beginning. Like from what I've seen, some of the engineers, they want to support every use case from the beginning. And like to me, start with what solves your current problems. And as you mature the process and you gain more knowledge, you gain more understanding of what you need really and what you don't need. So you filter out the noise. Um, and also, like one of the successful implementation criteria is prioritize usability and native integrations. It's like don't go this is what is called shaving the yak. If you start using different tools, open source tools and so on, and you combine them, you find yourself shaving the yak. So you have the problem with the infrastructure, then you realize that you didn't update I don't know, like open source tool, then you go update the tool, then you find an issue and you spend like a whole day just updating this. Yeah, part of like successful implementation, be aware of this and like keep it in the decision process. And also, if tests fail, like invest time to fix it. There is no shortcut actually, and this is I really like the philosophy no shortcuts, because I mean the shortcuts you need to pay the bill. Yeah, like invest time to find the root cause and fix them, because like this is how you build a secure path into having successful implementation of your deployment and CI/CD in general. The other points as well, as we said, it's people process tool thing. Train your team. It's not a cliche, because when we talk about training, people say, okay, I can watch some YouTube videos, I can read that, I can do it myself. Okay, you can do all this, but guys, be aware that training is part of the good work to be done, of the successful implementation. Invest time, money, whatever it's needed to train your team. And yeah, and look what the others are doing as well. It's like you may find a solution to your problems when you talk to someone else who already had the same problem and fixed it with the team. So we have seen it now, like people are more open to discuss different problems, and through the meetups, through different things. So don't like just go ask what's going on there, how people are doing things, and get inspiration from them. It's really helpful. And this is what we do at Brainboard. Literally, we talk to the users, get them feedback, and we just implement their feedback. So we listen to them. Sometimes, like, we do not reinvent the wheel. We take the feedback as it is, we implement it. And the last point, this is a very funny one. Even if we are talking about CI/CD automation and everything, like in the futuristic, expect to have some manual work to do. Even if it's automatic, sometimes you need to manually do things. So it's just something that you need to budget in terms of time, not money, in terms of time. That, okay, in some cases, I need to manually do things to fix it, or to deploy it, or to have it working. So this is not something that I personally, in my experience, I've never seen a company that plans for this point. Like they said, okay, we have a manual work to do on the CI/CD. Let's plan for it. So that's very important for all managers all over there, to help engineers and understand that sometimes it needs manual work, even if it's automated. So we came to the end. Thanks
Not
for
to the very end.
Yes, the demo. I almost forget
Yeah,
it.
because I think that our viewers are waiting for the demo, and we talked so far about the challenges and about the best practices of having a CI/CD for the infrastructure, and now we can see how we implement it in Brainboard.
That's true. Thanks a lot, Marcela, for reminding me this. And by the way, guys, if you want
Because
to take
time flew so fast in this discussion.
exactly, yeah, we are already over time. So I took here an architecture, one of my architectures, for example. This is a Brainboard. For those who doesn't know Brainboard, this is the tool the solution we are building. It allows you to visually design the infrastructure, but the purpose here is to show you the CI/CD. So we build our CI/CD engine. Let's say, for example, here I have my pipeline that I personally use, for example, this pipeline, but let's, for example, create a new architecture and call it webinar. So when I create the architecture, the pipeline will be reset. So here I do not have any pipeline. So now when part of the process, as we talked about, we mentioned that every solution has its own way of doing the CI/CD, and you need to learn the YAML and so on. We took it the other way around. We said, okay, what I want stages. Let's build them. First, I want to pick the most used ones, Terraform. And Terraform, I do the plan or verify. I want to check the code, if the code is valid. If the code is valid, is a condition to move to the next step. I personally use like all security tests, like TFSec. I combine it with Terrascan. I combine it with infra cost. So I want to understand the cost of the application, of the infrastructure. And this is like parallel tasks. So you have the stages. Every column is a stage. And within the stage, you have parallel steps. And this is what we call it. The execution is parallel. And you can build as many as this. You can, for example, for a task, you can require approval. And this is one of the greatest features that I really like, is we took it to the next level. You can get the approval for every task, which means if for the cost, you need an approval for a DevOps team, for a FinOps team, at brainboard.co, you notify the the FinOps team. And if for example, for security, you need the approval from security team, you just put here security at brainboard.co, which means everyone, you gather all people working for the infrastructure into the same process, into the same platform, into the same solution, and everyone will see the output of previous executions and take the right decisions. And you can put approval. After that, once it's done, you can, for example, notify teams by email or by Slack or by whatever the means you want. Then, all right, everything is good. You can also use OPA, by the way. You can write the policies here, and you can write as many policies as you want within the stack. Now I can say, okay, I want to deploy the infrastructure after all this, and I do the apply or destroy. Once the infrastructure is deployed, you can notify maybe any external system like ServiceNow, Jira, whatever ticketing system external, or maybe send a notification that the infrastructure has been deployed. And you can, like you have here, visually we built in a few minutes a complete pipeline, and that we can trigger. So I will show you one of the pipelines, the one that I had before here for this infrastructure. Yeah, this is like the battery of the pipelines that I have. And when I trigger them, like I can see the output of every step. So here I have the history of all what happened to my infrastructure. And I can go here, I can see, okay, the cost estimation, this infrastructure will cost me, let's say, $29. In terms of security, I have some homework to do. I have some security things to fix. So I can see it here. And as I told you, like with TFSec, we picked the most used plugins, the most used open source tools, we call them plugins into Brainboard, and we added them. So you have here link to the documentation on how to fix it. So you can copy the link up on the documentation and fix what need to be fixed. You have and you can see the complete pipeline with execution. And as we wanted to bring real value to the users. And by the way, guys, those who are listening to us, please provide feedback when you test it. We are really looking for feedback and your use cases, your challenges, anything that you want to see. Just let us know. We'll be happy to, as we are building it specifically for the infrastructure, we'll be happy to have your feedback. So you can now, with this complete template, with this complete workflow, you can create a template out of it. So here I just call it webinar, and now I have my complete workflow in a template, which means if I create a new architecture, let's say I create a new architecture and call it webinar 2. When this architecture is created, I will not create the pipeline manually as I did before. I just go to the template here, browse them, pick the one that is called webinar, and clone it. It will be created automatically. It will be added automatically to my infrastructure. It may contains the API keys for any solution, the complete configuration, and just click on Run Pipeline, and it will be run. It will be run, and I can have a history of all what happened to my infrastructure. So now we came to the real end, Marsela. So
Yes.
We will be happy to have a virtual coffee and chat about any topic you want to talk about. Feel free to reach out to Marsela. It's one of our experts, or to me, or the team is here. We'll be happy to help. And stay tuned for the next webinar. We're going to choose one of the topics that will help you in real life and share it with you and grow up all together. Marsela, have a nice evening.
Thank you. I wanted to say that we will respond to all the questions from our viewers, because I saw that there were many questions and we weren't able to respond lively, but we will of course respond. And if there are topics that you want to discuss in the future, you can comment, and we'll make sure that we will have as many webinars as possible in order to help our users.
Yes. Thanks a lot, everyone. Take care and have a great CICD implementation. See you.
See you. Bye.